Hey guys, so in this video we're going to finish up our notes on solving quadratic functions algebraically. The last two methods were square root method or completing the square and the quadratic formula. So just as a review, remember there was four methods. There was the zero product property, there's factoring, which was the tic-tac-toe boards. Today we're going to go over square root method and then the quadratic formula. When you are taking a test or when you're doing the EOC, you're going to have to pick which method to use. The quadratic formula will work for every single problem no matter what. So make sure when we go over that you pay attention and you memorize that formula because it's not going to be on your reference sheet. Factoring you also need to be comfortable with because sometimes they will ask you to factor the quadratic instead of solving. If they ask you to factor it specifically, it will be factorable. So don't worry about it being like a super difficult equation that you can't factor. If they tell you to factor, you can do it. So make sure you know how to do at least factoring and the quadratic formula. If the square root method is confusing, don't sweat it. You don't ever have to use it. It's just an option. So let's go right into this. So with the square root method, okay, our first step is going to see that our quadratic function is written in the right format. So it needs to be written as ax squared plus c equals 0. So for our example, we're going to use 3x squared minus 6 equals 0. If it's not written in that form, I would not use the square root method. Instead, I'd either use the quadratic formula or I would factor it. So after that, your second step is to get x by itself. So for this example, to get rid of the 6, since we're subtracting 6, we're going to add 6 to both sides and get 3x squared equals 6. Then we have to get rid of that coefficient 3, so we're going to divide both sides by 3 and get x squared equals 2. Okay, our very last step is to take the square root. That's why it's called the square root method. So I don't know what the square root of 2 is because 2 doesn't have a square root. Right? It's going to be an irrational number. It's going to give us a really long decimal when we put it in our calculator. So we're going to just write our answer as x equals the square root of 2 or x equals the negative square root of 2. And remember, when we are solving quadratics, it's our x-intercept, so there's always two answers. So I have my positive x squared as one answer and my negative my positive square root of x as one answer, and my negative square root of x as my second answer. Now let's move on. If you need to, go ahead and just pause the video, finish writing these notes. When we unpause it, we'll talk about completing the square. So for completing the square, it is the process of adding a term to the variable side of a quadratic equation to transform it into a perfect trinomial. That is really confusing. So we're going to look at two examples. I don't suggest using this method, but we have to go over it. So we're going to go over it very quickly and then move on with our lives. You don't even need to write this in your notes. If you want to, you can, but you don't have to write this down. So for our example, we have x squared plus 10x minus 6. So the first thing I'm going to do, my step 1, is to isolate the variables. So I have x squared and I have 10x. I'm going to leave those on the side they're on. The only thing I need to worry about is that minus 6. So I'm going to add 6 to both sides. So now I have x squared and 10x on one side and 6 on the other side. So step 2, I need to make my left side a perfect square trinomial. So to do that, I'm going to look at my coefficient for x, which is 10. To figure out what that third number is to make it a perfect trinomial, I'm going to divide 10 by 2, which is 5, and then I'm going to square it. So 5 times 5 is 25. So 25 is the third term I need. That is going to be my perfect square. So I'm going to add 25, but if I add 25 to one side, I have to add it to the other side. So I end up with x squared plus 10x plus 25. That's a trinomial, and it's a perfect trinomial because 25 has a square root. And I have to add 25 to the other side, so 6 plus 25 is 31. Okay, third step. Now we're going to rewrite this as a factored trinomial. So x times x is x squared, so that's how I ended up with x plus in my two parentheses. And then I have plus 5 because 5 times 5 is 25, and 5 plus 5 is 10. So when I rewrite this, I'm going to end up with x plus 5 squared equals 31. Now I'm going to take the square root. So the square root of x plus 5 squared is just x plus 5, and then I have the square root of 31. 31 doesn't have a square root, so we're going to just leave it as the square root of 31. That plus over a minus sign means positive or negative. So remember, it's going to either be the positive square root of 31 or the negative square root of 31. In order to get x by itself, I need to get rid of that plus 5, so I'm going to subtract 5 from both sides. So my final answer is negative 5 plus or minus the square root of 31. Again, this method's really complicated. I would just avoid it and use the quadratic formula instead. So if you want to write that down, go ahead and pause the video, and then we will go over the quadratic formula next. Okay, so for the quadratic formula, this again is a formula you need to memorize. First step is to make sure that the equation's in standard form. So ax squared minus bx plus c. So for our example, we're going to use x squared minus 6x plus 3. Step 2, we're going to find what a, b, and c are. So my a equals 1, because there's no coefficient, so we assume it's 1. My b is 6, and my c is 3. Now I'm going to plug those into my quadratic formula. So this is the part you need to memorize. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So when I go to plug this in, I'm going to start with the numerator. I'm going to start with the top of the fraction. So negative b, so that means negative 6 plus or minus b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 3. And that's all under my radical. Now I'm going to do my denominator, or the bottom of the fraction. So I have 2 times a, which is 1, so just 2 times 1. Okay, so first thing we're going to do is simplify what's underneath the radical, starting with my exponent. So negative 6 squared is 36. Then I'm going to do my multiplication. So 4 times 1 is 4. 4 times 3 is 12. So I end up with 36 minus 12 underneath my radical. So always do it in that order. Do the square part first, do the exponent first, and then do the multiplication for 4, a, and c. Okay, now I'm going to subtract, so 36 minus 12 gives me 24. So now I have 6 plus or minus the square root of 24 over 2. Once you've got to this part, this is where you're going to write your two separate solutions. So I'm going to write one as 6 plus the square root of 24 over 2, and my other one is going to be 6 minus the square root of 24 over 2. Technically, you could leave your answer just like that and stop, but on the next slide, I'm going to show you guys how to simplify it further if they ask you to keep going. So go ahead and pause the video if you need to keep writing, and then I'll show you how to simplify the answer even more on the next slide. Okay, so if they ask you to write your answer as a decimal, or if you have a perfect square, so a number that does have a square root, this is how you'll keep simplifying. So for example 1, I'm using the same exact answer we just used. So if I use my calculator and I put in the square root of 24, I'm going to get a really long decimal. I'm just going to round it to 4.9. So I end up with 6 plus 4.9 over 2, or 6 minus 4.9 over 2. Now we're going to just add and subtract. So 6 plus 4.9 is 10.9, and 6 minus 4.9 is 1.1. Last step is to divide. So 10.9 divided by 2 is 5.45. And 1.1 divided by 2 is 0.55. Okay, I have a second example for you guys also. I'm going to go over it quickly because it's the same thing. Only thing I changed was instead of 24, I'm using 25 to just show you what you would do if it was a number that does have a square root. So 25 does have a square root. A square root of 25 is 5. Because 5 times 5 is 25. So when we do the square root first, we'd end up with 6 plus 5 over 2, or 6 minus 5 over 2. Now we're going to add and subtract. So 6 plus 5 is 11. So I get 11 over 2. Or 6 minus 5 is 1. So I get 1 over 2. You can leave your answers like that if you want to. You can leave it as an improper fraction as 11 over 2. Or 1/2, or you can simplify it, so it would just be 5.5 or 1/2, and that's it. As always, you can rewatch this video. It'll be on YouTube and on Schoology, and if you have any questions, don't hesitate to send me a message on Remind or on Schoology. Your capacity matrices I want turned in next week. So if you have any questions, do not hesitate to contact me over the weekend for extra help.